In this video, we're going to be working on this problem. As you can see, it's a quadratic functions, and we want to find the range of this function, find the inverse formula, and then talk about the domain and range of the inverse function. Now, before we get into these parts, let's just analyze this function so that way we know how to graph it, and then we can proceed to finding the inverse formula. So if you take a look at this function g, we're also given that the domain of this function is only on the interval 1 to infinity. So of course, because of that, this is a 1-to-1 function. So the inverse exists. Now, if I try to graph this function, I would probably want to find a vertex because a parabola has a vertex. So let's go ahead and do that. Let's first find the vertex. So in order for me to do that, I can go ahead and complete the square and then find its vertex. Then we can ready to graph this. So let's complete the square. So g of x is equal to, so before I do that, I'm also going to leave a space because we're completing the square. So we have x squared plus 4x, and we rewrite the 7 all the way far away. So by completing the square, we take half of the coefficient b and we square it. That's what goes on both sides. So we take b over 2 and we square it. So our b is 4. So that would be 4 over 2 square. So that would be 2 square, which is 4. So I'm going to add 4 here. And to keep it balanced, I will also add 4 to the left-hand side. And now I have completed the square. So simply my x squared plus 4x plus 4 becomes x plus 2 squared plus 7. And on the left-hand side, we still have g of x plus 4. To solve for g of x, we subtract 4 from both sides. And that gives us g of x is equal to x plus 2 squared plus 3. So that will be our g of x in standard form, or a times x minus h squared plus k form. So from here, we know the vertex of this function happens to be -2. That's the x coordinate, and the y coordinate is 3. So that's the vertex. Now, if I were to draw this, it will look something like this. So suppose our x and y plane is right here, and -2, 3, let's suppose that's right here. So that's the vertex, and the parabola is opening upward because this is positive. So it's going to be a parabola that looks like this. Roughly drawing, that's how the graph looks like. Now we're only looking at the graph when x is on the interval 1 to infinity. So suppose 1 is here. So we're only looking at this graph from here. So that's a very tiny piece to look at, but let me see if I can make it larger for you. So we're only looking at this portion of the graph. So the domain that we're looking at is from 1 to infinity. So that means the graph that we're zooming into is only, so when you plug in 1, we get about, so plug in 1 into the function right here, we get 4 times 1, that's 1, plus 7, and then plus 1, that will be 12. So we know that the function at 1 is 12. So when x is 1, our function value is at 12. So that's the piece we're looking at. So this other half of the parabola that we drew above doesn't exist. Doesn't quite look like a parabola, but I hope you got what I mean by that. So now let's find the inverse of this function. So that's our g, only on the interval 1 to infinity. And we want to find the range of g. Well, I see that the lowest the function attains when x is equal to 1 is this value right here. So the range will be from 12 to infinity. So the answer to the first part will be including 12 to infinity. Well, Now, we could actually answer part C and D just based on what we have, because you don't need the formula to find those. Well, the domain of the inverse is actually the range of the original function, and the range of the original function is answered to part A. So that would be 12 to infinity. And then range of the inverse is actually the domain of the original function. So that means we already have that. That's given to us in the problem, 1 to infinity. So the only thing left to solve is to find that inverse formula. And the way we're going to do it is from this step right here. When we have g in the completing square form, we can simply call g of x is y and follow procedure from there. So let's go ahead and do that. So we know g, as we solved it, happened to be this function. G of x is equal to x plus 2 squared plus 3. So just taking that formula. And now we're going to let g of x be equal to y. So then we have now y is equal to x plus 2 squared plus 3. And after this, you interchange x and y. So y becomes x and x becomes y. So we have x is equal to y plus 2 squared plus 3. And from here, we're going to solve for y. So let's go ahead and do that. So I'm going to go ahead and subtract 3 first from both sides. That gives me x minus 3 is equal to y plus 2 squared. And then we take square root on both sides. Now you also have to remember, if you take a square root, you have to put plus and minus. So that'll be plus and minus x minus 3 equals square root of y plus 2 squared. And now these can cancel out. So that leaves us with plus and minus a square root of x minus 3 is equal to y plus 2. And finally, to isolate y, we subtract 2 from both sides. And that would give us y is equal to negative 2 plus and minus a square root of x minus 3. And that is our inverse function, but we need to be careful. Is it the plus or the minus? So we have to make a selection here. So here, you're going to select either plus or minus based on the domain of the original function. So if you go back to the problem, the function is only on the interval 1 to infinity. So that means we're looking at the positive square roots of that. So therefore, our inverse formula, the inverse function of x, it's going to be, so we are going to select the positive, since we're only given the interval 0 to infinity. So that will give us negative 2 plus a square root of x minus 3. So there we have our inverse function. All right, so this is it. I hope this helps you understand quadratic a little bit more. Right, I'll see you guys next time.